So today we developed an American Sign Language classifier, or ASL classifier for short. This was created by me, Srivanth Reddy.
Sean Kim.
Chang.
Francisco Castro.
Nahom Ezra.
And Aditya Dubey.
Here are contents. Our purpose for creating the ASL classifier is that we wanted to create something for people who do not fully understand ASL or who want to learn the language. Not many people today actually know ASL and they want to learn it. So we decided that creating this product would serve as a good aid for those people.
We obtained our data from a variety of different sources. For example, we found different image sets on Kaggle. We also found data sets of images just on the web. And we also took personal photos of our own hands to train our model. For preparing and processing the data, we use an Asl Alphabet Chart to help correctly identify the different ASL characters that are present in the different images in the data set. Most of the images were comprised of close-up images of certain ASL hand gestures. In total, there were over 11,500 total labels made. And there were 200 to 600 labels per letter.
We use YOLO as our algorithm in order to detect certain hand signs in the picture. For YOLO to be able to identify the ASL, we had to label data using label box in order for YOLO to conceptualize different hands and hand signs.
Our difficulties for the most part had to do with collection of data. We had to simultaneously get larger data sets and more of a variety, so we could get everything. So we solved this by importing different data sets from the web. We learned Python and the lessons we learned were that we learned Python and how to implement it into AI. We also learned how to create websites using Flask, and we learned how to get data sets from other sources and label them in label box.
Thank you. Now we'll be moving on to the website portion.
Now for our website, this is the ASL classifier where we're detecting different American Sign Language letters. So right here we have the button Try Now. And right now I'm just gonna grab a quick sample image right here. So when we click on it, it's gonna give seconds and it's our results. So our model predicted the letter S with 99% certainty. And as you can see over here, it is the letter S. So our model was created with around 10,000 pictures plus from multiple data sets and personal data sets over our 3-week period in AI camp. So if our image appears to be incorrect, so make sure that there's a few guidelines you want to make sure that you're following. So make sure that it's like a relatively clear ASL gesture with like decent lighting. And also just note that it has to be like really close up to the camera, or otherwise it's going to have a little bit trouble detecting when it's further away. And the last thing is that this thing will only work on ASL alphabet letters. So it won't work on like certain gestures like good morning or the color yellow.
So if you have different backgrounds, this thing won't work, right?
Yeah,
you can answer this. Yeah, I actually tried it out on like the website when it was finished. It doesn't struggle too much with the background. It struggles when when you take it far away. So in our data sets that we imported, in hindsight, we tended to import like data sets that were just all like pretty much at the same proximity. So like extremely like close-up images. So for example, like we would import a data set specifically for the letter A, and in it will show a varied data set based on position, but not really on proximity. So that might have compromised our ability to say, if I were to like do a C right here, I tried this, it gave me a 33% certainty of M. So it has trouble isolating certain sign languages when you're letters when you're far away.
Gotcha. So
Yeah.
what's the sort of like ways to remedy that? I guess this shows a proof of concept, but let's just say you want to bring this to the real world. What are the steps that we should do?
You definitely need to have a more varied data set. So again, from what I was able to gather and looking at the Kaggle data set we used, it was far too too much of just the same image over and over again.
Yep, makes sense. Makes
Yeah.
sense. Yeah.
I have a question. So
Yeah.
I'm just curious. So I know in ASL, I know for the letters, so there's two letters, someone asked this in chat as well. There's two letters that have motion when you do letters. And so what I'm curious on, so I and J, I know that you can't really distinguish them because J is a motion because they're both like this, right? And then J's like that. I'm just curious of how it would work when you compare I and J.
We actually came up with a solution to this. We basically took the blur frames of movement, or like, say for instance, I is static, but J you'd have like characters like this or like this. So we'll take this as J, the middle of it too. It seemed to work out pretty well. I kind of tested it for myself using stock images, and it worked fine. And however, I couldn't really test it on like here because back then the lighting was pretty bad.
And then what did you do for C? Was it the same deal?
For C, I mean C is
or Z.
Z is the same deal pretty much. Yeah.
I have a question on whether or not, so like in your data set, were all the skin colors different, or like was there variation in skin color as well, or how was that handled?
From what I was able to tell, each data set was from like a different person, so there was variation, but between the data set for A and B, there's definitely like variation in skin color. Just so I didn't really get any problems based on skin color.
Okay, interesting.
So actually, I just wanted to say that the question Rinav asked was very, very important. You know, there's a lot of people say, hey, like maybe, this works for light colored, folks and doesn't work for dark color, folks. It's really because we just don't have enough data. And I think that's a lazy way to say that we're not responsible, right? Because, what data we fit into the program is essentially how, we decide that, right? So I think it's very important for us to test that and be respectful for different skin color and everything. So I think that's pretty important. Yeah.
So I actually have another question. So I saw that you could input images. Will the same thing work with videos? Because like if you're doing one letter, like how are you going to like have like a full conversation? Would you be uploading every image one letter by one letter?
How about we like try that actually? So I'll send a video of a hand gesture and see like if you could download it.
I can answer that. So there's a couple of ways you can do it. First of all is that video is basically composed by frame, right? So naive kind of model is just like you process so fast, because like YOLO can do something like 50 frames per second using a good GPU, and your video is only come at 24 frames per second, right? Most likely. So you can do like frame by frame, and naive model just like classify them like frame by frame, which is what you see at ai-camp.org. You see that girl is like lifting her mask, right? That's actually come from that. But you can also, right, like basically play the information that video is basically a time series data and their relationship among the time series, right? You can also play that. But I haven't really looked into like how we're gonna do that, but I'm pretty sure that is something we can do. Yeah.
Yeah, and like I don't think it'll like actually work well because we didn't train it with any like videos, so it might be pretty confused.
Yeah.
Also, I'm trying to like download a GIF to use it, but was your question answered?
Yeah, I think I understand.
All right.